All right, let's do a problem, a linear inequality problem, and an absolute value function. Let's start with 2x is less than 6. Well, you graph this simply by first solving it for x. And you solve this for x by dividing by 2. Then you'll have x is less than 3. Now, this is graphing linear inequality in two variables, so you're going to treat this as if it had an x and a y value. Well, what we're going to do is first draw ourselves an xy graph, and then you got to ask yourself the question, we got to graph when is x equal to 3? Well, first, where is x equal to 3 on an xy graph? The question is, when is x always 3? Well, x is always 3 here. Grab this line. What am I talking about? Well, it's 3, 0 here. It's 3, 1 here. 3, 2, get the point. All the way. 3 something. This is the line x equals 3. And you read this, x is less than 3. For what values are x less than 3? Well, this one is going to be all of these values over here. It represents every ordered pair over here. So what I'll do is shade all of this to the left of that line. This is the actual solution for this particular equation. It shows every every ordered pair that makes this true. Let's do a different one. I think it'll help because this one it's hard to see the y value in this, but let's do another one. Okay, here's the next problem. Hopefully, I think this will help. If I give you, let's say, 2x plus 3y is less than or equal to 6. Well, what I want to do is solve this first. Basically, I want to know which ordered pairs will make this inequality true. I want to know every possible ordered pair that will make this inequality true. Well, to do that, you first solve for y. So I'm going to take this, solve for y. And the reason I'm going to solve for y is because I need to graph the equation. And that'll show me something. And I'll show you that in a minute. So I got 3y is less than or equal to negative 2x plus 6. Divide everything by 3. So y, I'm just left out writing out that step, is less than or equal to negative 2 over 3 x plus 2. Well, here's your equation. The question is, what ordered pairs will make this true? What are all the possible ordered pairs? 5 comma 4, 7 comma 8, negative 3 comma a billion? I don't know. Let's see. Let's draw an xy graph. First thing you want to do is graph the equation y equals negative 2 over 3x plus 2. Well, you do that by drawing out your equations, writing everything out, and you graph this. A few ways to graph it, but the easiest way probably is to plot your y-intercept. So I'm going to go up 2, put a dot. I'm going to use my slope to get to my next point, which means rise negative 2, run 3, go down 2 over 1, 2, 3, put another dot, draw a line. Since it says less than or equal to, I can go ahead and draw a solid line. If it was just less than, I would draw a dotted line. Okay? What does this mean? Which solutions or which order pairs will make this true? Well, what you can do is do some test points to test this. Let's test any ordered pair. And if I test a point, let's say I'm going to test this point here. This is the ordered pair 0, 0. If I plug in 0, 0 into this equation, is it true? Let's try it. 0 is less than or equal to negative 2 thirds times 0 plus 2. So I'm saying, is 0 less than or equal to 2? Is 0 smaller than or equal to 2? The answer to that is yes, it is. So that means here, this ordered pair makes this true. So what that means, I'm going to shade on this side, because this side represents all the ordered pairs that will make this particular equation, inequality, true. And we'll do the same type set of problem with part 2.